Yeah, good afternoon, everyone. Yesterday, we have discussed about acid properties, acid properties, and the transaction stages. So, acid properties, we have discussed the basic concepts of transactions, like these properties. Then, transaction states, we have discussed. We have discussed about the five states of the transaction. So, one was the active state, next one partially committed state, and the committed states, and like failed states and aborted state. These are the five types of transaction states we are discussing in study class. Okay. Now see now what is concurrent execution and recoverability transaction. What is concurrent execution? See, the transaction processing systems generally they allow multiple transactions. Means we have to know to the database, okay. And this database allowing multiple transactions. This is transaction A, and this is B, this is C, and this is D, so on. Okay, this the transaction processing system. So there is a system called transaction processing system, which is allowing multiple transactions. That means multiple users can access the data. Multiple users can access the data, and they access concurrently. They can access concurrently. So that means allowing multiple transactions to update data concurrently, which causes several complications. Okay, they cause several complications and consistency also will have a problem that take extra work. And it is far easier to insist transactions which run serially. So that means one at a time. It is one at a time. So it's starting from one after the previous one was completed. The two good reasons for the following along the concurrency. So what are those we will see? The transaction consists of many steps. So some involve IO activity. Some involve IO activity. And some transactions involve CPU activity. Yeah. The CPU and the disk same control systems which can operate parallel. That is, the IO activity can be done in parallel with the processing of the CPU. Then the parallelism of the CPU and IO system, which are therefore be exploited to run multiple transactions in parallel. Yeah, is one of the reasons. And will a reader write on behalf of one transaction is in progress among those. The other transaction can be run in the CPU. Some other transactions they displayed in GA10 the reader writes on behalf of the broker. This is one of the multiple transactions. So all of this increase the throughput of the system. The throughput means you can understand its performance. Throughput means your performance. So correspondingly, the processing and discrimination also which increase. Increase. In other words, the processing is less time idle, cannot perform any useful work. So these are the primary reasons which will improve the throughput and the research utilization. To reduce the waiting time, this read and once we will understand clearly. So there may be a mix of transactions running on system, some short and some long, some short transactions, some long. The transactions means legally, a short transaction may have to wait for a basically long transaction. Okay. If any long transaction, the short transactions will wait a period of time. We need to unpredictable delays in the transaction. This kind of unpredictable delays uh, in short transactions will wait. And if the transactions are operating in different parts of the database, so it's better to let them to run concurrently and sharing the CPU circuits and disk access. Number. Therefore, kinds of reducing the waiting time. Let's see. Into that. Yes, we completed the chapters in this. Completed the business fundamental relational model, integration model, relational model, normalization we completed, database architecture, data models we completed, storage structures we completed, vector file automation, storage access, database transactions, okay. Um, SQL introduction we completed the types of languages we completed, ADL commands, remember command, DCL commands, TCL commands we completed. Install every topic we completed with. Just you see the revision of the all the chapters once again. See, testing of serializability. Do we test a serializability just to see once? A serialization graph is used to test the serializability of the statement. It can be used. Serializable graph we use to test the serializability of the schedule. Just see the statements once. The statement once. So actually a schedule guess. That is a schedule called yours. Your for this years, for this years, so we construct a graph, which known as a precedence graph. Known as a precedence. Yeah. Now this graph has a pair of vertices becoming. So we consist of set of vertices. This is and we consist of a vectors. Vectors. We have vertices and we have edges. The edge stands here, the gravities. Now, the set of vertices is used to contain the transactions participating in the schedule. Now the set of edges is to contain all edges, all edges, which one of three conditions that holds. Based on these three conditions, the set of edges closed. Wait and more it is. Yes, see these two conditions. It's not on the condition ones. Yes, noted down this. Now these are the two conditions. Create a node with Ti plus Tj. Ti executes right here before Tj executes read out. So you see this explanation here. So for the read operation, in a T1, no subsequent writes to node A. So that is no new edges there. So for the T2 also, no subsequent writes to B. There is no new edge. and T3 also like that. And but B subsequently is read by T3 to add edge, which T2 implies T3, and is also T3 implies T1, which is T1 implies T2. Okay, we get some conditions here. Now the precedence graph for the schedule S1. The time, these are the transactions here, TTA, read B, and read C, and which is the read operation and the write operation, read operation, write operation. This is this recoverability of schedule, the recoverability of schedule. Now, sometimes the transaction may not execute completely due to some software issue. Sometimes the transaction may not execute completely due to software, some software issue, like system crash or hardware failure. There can be any kind of a reason for the failure. So here we can say that there can be software failure and there can be hardware failure. So among these two, there can be any kind of failures or will occur. In that case, what will happen? A failed transaction has to be rolled back. So we have to recall the transaction and we have to roll back the transaction in the failed case. In terms of failed case. But some other transactions may also have used value produced by the failed transaction. So we also have to roll back those transactions. We also have to roll back those transactions. You see this table once. Now this table shows the schedule which has two transactions are there. Two transactions. Okay. The T1 reads and writes the value of A is T1. T1 reads the value of A. What's the value of A? Okay. And that value is read and written by the T2. This T2 is there. This value read and written. Okay. And T2 commit but later on. T2 commits but later. So because the what will happen is T1 fails. So this is a failure point. And due to the failure, we have to roll back T1. We have to roll back the T1. Now T2 should also be rolled back because it affects the value written by T1. But T2 can be rolled back because it already committed. This type of schedule is known as irrecoverable schedule. Irrecoverable schedule. This type of schedule. Now recoverable with cascading rollback. This example. See the example was table. Draw the table otherwise. Also recoverable with cascading rollback. Recoverable cascading rollback. The schedule will be recoverable with cascading rollback if teacher reads the update value of yeah, and commits TJ is delayed, will commit out. Okay. Below this table shows what the two transactions. The transaction T1 reads and writes A, the commits. Is a transaction T1, and transaction T2, which reads A, writes A, the commits. Okay. And the value is read and written by the T2. See, what are the transaction T1 is the read, written, a committed. That value also be taken by the transaction, which is read, written, and the committed. Okay. Read and written, committed. And the stable resource is scheduled with transaction. This transaction T1 and transaction T2. Transaction. We go down this. So what is the transaction isolation implementation in DBMS? Transaction isolation implementation in DBMS. Transaction isolation implementation in DBMS. Now, in order to determine if a transaction is serializable or not, we need some sort of analysis of transactions. I cannot simply say that any serial schedule transactions are conflicting or serializable. In order to determine the serializability, the isolation, we use precedence graph. Now, this is a directed graph. So, one transaction is to be transaction to be. Now, directed node between transactions drawn if there is any conflict. So, example here shows that this example, which is a this nodes for each transaction by a direct line from T1 to T2. So it's T1 to T2. Okay. So T2 reads the data X after T1 writes it. T2 writes X after T1 writes it. A direct line between T1 and T2 is drawn. In schedule, if you have the combination of transactions in T1 and T2, I think stable. So it shows that what schedule is said to be completely serializable. Now, we don't know that the sequence graph is cycle. Exactly. The graph forms a cycle, then it cannot be complex. So below set of transactions and its precedence graph, it forms a cycle and hence it cannot be sequence. So table, what able to see. So these are the examples for the transactions. The example for the transactions. Now, once again, we will revise the what are the SQL commands or SQL commands we already studied. Once again, we will revise all the concepts. Once again, so we completed all the concepts from the textbook, all the blocks. So once again, we will revise the important concepts. So many times we are discussing about the SQL structured query language. This language is having subtypes similar commands. It is having subcommands you can call subtype of language. You can call. What is the commands are given in C. The commands which are related to the transactions of commit, go back, save point, set point. So what is the commit piece? Is once you commit to that you cannot roll back again. Once you commit to this, to roll back means to get the transaction back again, you can use this option. This option. Now what I say point is it creates a point with the groups of transaction and which to roll. So transaction places in transaction with the transaction control commands. Transaction control commands are only used with the YAML commands. YAML commands, what are the YAML commands? Manipulation commands. It's a update, data manipulation language command. There are data creation language are the data manipulation language are the data control language are the control language are the these are the destructive commands here. Now it is coming to the SQL. The SQL is having the commands. One part is you have to remember all the commands. The commands you have to remember. The second point you have to remember is data types. You have to remember data types. So what is the data type you have discussed in your earlier class? So what kind of data you want to insert in the table? What kind of data you have to insert in the table? You decide what the data was stored. Example, there's this table. Let's say this is student article number. Let's say this is the name. So this is the gender. Let's say this is one. Article number, if you say 111, then you say the name you can say some ABC. ABC. The gender you can say one number you can say 1, 1, 2, 3, 4, 5. Now into this article number column, whether you want to enter numeric or alphabet is decided by the data type. That is what we need to understand. How we want to understand this. Into this column, inside the table, so what kind of data to be inserted decided by the data. Decided by the data type. The data type is also having some kind of values range. Values range. What is the range of the data to be inserted? What is the range of the data to be inserted? It is decided by the range. See this. This is also one range. Okay. This range is related to number. The number can enter between -84 to plus 127. And the float number can enter up to 1 to 126. So, and if you take the number here, that is the floating point. If you take down again, say it is stable. It's a data type. So it's a range from to the range from lower value to the higher value. If you take a bit, the bit will store where the value from 0 to 1. If you take tiny int, it will take 0 to 2 by int. If you take small int, this minus 32,768 to plus 32,767. If no symbol is there, means it's a plus. No symbol is no symbol means it's a plus 1. And it will be entered with longer same value have to try to remember in shortcut. Then after that, the begin is that there's a range. And after decimal is there, it's the range. After numeric is there, it's the range. And float is the range. So these data types will show us what kind of value we have to enter into the table. And also they show us that what is the range of value to be entered into the table. If you know these two things very well, you can enter the data and enter the data into the table. First point is what kind of data to be inserted. The second point is what the range of the data. What is the range of the data to be inserted into the table? That's one more point to be understood. Okay. Yeah, one more type is the date and time related is still date and time. Just to note down this table and we will discuss. Just note down this. Some data type we will use date we will use. The date format is year, month, and day. Year, month, and day. There is a date format. Next one, time is the time we use is hour and minutes and seconds. Then the date time is the date time combination is year, month, day, hour, minutes, seconds. These are data types. Then for the timestamp, you can see which stores the number of seconds passed. It seems the Unix approach. You can say it up also. So this is the formula. But the year, you can say, which stores year in two-digit format or in four-digit format. You can say year is in year is four-digit format is there. Year four-digit format is there. That's you can store in the two-digit format also. But the range is 19.1 to 21.55 in four-digit format. And the range two-digit format is representing to 72.69 and it's representing 1970 to 26. That is the remaining data types. You can see one more character related data types and string data types. You can see character related data types. Char we will see. The char is for mixed length, pixel length characters. It is. The maximum is 8,000 characters. Next one is a varchar is their variable character, and which is the maximum length also 8,000 characters. And next one is a variable character max is there. It's a variable length stores with provided max characters and not supported in mice equalities. The next one text is there and it's a variable length storage with a maximum of 2 GB data it is. Maximum 2 GB data. These are the character related data types. So if you wanted to store any character into the database, into the table, then you have to use these data types. So these are the list. And some of the other data types are Unicode characters. These are Unicode characters. Let's see, Unicode characters. Next one, NCHAR it is. NCHAR, which is pixel length with maximum length of 4,000 characters. Pixel length and maximum length of 4,000 characters. That is NCHAR. Next one, NVarchar is will take the maximum length of 4,000 characters. Is also. And NVarchar max will take max characters. This is. Then ntext will take variable length storage with the maximum size 1 GB data. Maximum size 1 GB. Okay. Now these are the Unicode character and string data types. Unicode character and string data types. And SQL binary you can see if you take SQL binary if you take the binary is there the pixel length with maximum of 8,000 bytes. If you take the binary data types and the variable binary will also will take 8,000 bytes. So bytes means 8 bits it is. Say bytes means 1, 2, 3, 4, 5, 6, 7, 8. So these 8 blocks together is called 1 byte. 1 byte. Okay. So that is a variable binary. Then next one variable binary of max is also max bytes. Then for the image, you take the variable length storage with maximum of 4 GB binary data. Please. You take image. Now, data type, if you take miscellaneous data types, you go for miscellaneous data types. You go for miscellaneous data types. The one data type is log, log. That is a character large objects that can hold to 2 GB. That can hold up to 2 GB. Then one more type is VLOG, binary large object. This is CLOG means character large objects, and VLOG means binary large objects. Then this one is XML for storing XML data, and JSON is also there for storing JSON data. JSON also there for storing JSON data. So these are the types of data types. So whatever the data type is useful, it depends on what kind of data you are storing inside the database. So based on that, you can select the data type. Now coming to the constraints, if you take constraints, the constraints are set of rules. You take constraints here. The constraints mean set of rules depending on Oracle tables, which is to ensure the data integrity. Ensure data integrity. Now these rules are enforced in the placed for each column or set of columns. So whenever the table participants in data action, now these rules are validated, there is exceptions upon violation. Exceptions upon violation. The available constant type are not null. Constant type are not null, which is primary key and the unique check point. Now these are relations. This is an optional constant. This is a constraint we have seen, the normal. So this means that normal constant means that the row must have a value that the value specified as normal. It means you should not be empty. You have to enter some value into that. You have to enter some value into that. If a column is specified as not null, the Oracle RDBMS will not allow rows to be stored to the employee table that violate this constraint. It can only be defined at the column level and not at the table level. That's a normal constraint. Okay. Constants, the unique constant is that now sometimes it's necessary to enforce uniqueness for a column value. That's not a primary key column. The unique constant can be used to enforce this row, and Oracle will reject any rows that violate the unique constant. So any constant ensures that the column values are distinct and without any duplicates. It's the unique constant says about the column values are distinct, that is, without any duplicates. That is the unique constraints. That is the unique constraints. Now see what is a primary key. Primary key we already discussed it is. Primary key we already discussed. So whenever if you make any column as a primary key, that column will not accept any duplicate values. So how to apply the constraint on the column is write in the column name, data type, the constraint. You have to put the constraint, what type of constraint you are applying on that. Next one, see the primary key that is. This is the type, this is a syntax. It's an ID, the column name, the data type, the constraint, the column name, then which is the primary keys. That is the primary key. The next one is a foreign key. What is a foreign key? In one table, it is a primary key. Another table, it is a foreign key. If you wanted to We wanted to link one table to the another table. Wanted to link one table to the another table. We have to use these concepts. We have to use these concepts. Now, foreign key is a key that is used to connect two tables together. This one. That means one table data I can transfer to another table, and then the another table data can transfer to another table. So we can access both these two tables data. We can access by giving a query. For these two tables data, we can access by giving a query. That is what the foreign keys. Foreign. Now, foreign key is a field or collection of fields in one table that refers to the family key in another table. Listen to what I said now. The table contains the foreign keys called the child table. The table contains the foreign keys called child table. Table containing the foreign key is called the child table. The table containing the candidate key is called the reference or parent table. Reference or parent table. Just draw the two tables once. Draw the two tables once. We will discuss these two tables. Yeah, this is a foreign key, these two tables. These two tables, you draw the two tables, then we will understand. Yeah. Now see this. This is a column. This is a column. And this is a column. There are three columns are there. This is the row one and two, three, four. Four rows are there. Now this table is a student table. Table name is called student. Okay. The student table is having these many columns. And the same student are these many rows. These many rows. Okay. And next one more table is a course registration table. See course registration table. Here see this is one column and this one column. Two columns. The rows are these many rows. These many rows are there. See. Now the student ID, this is a column in the student table. In the student table, the student ID is there. This is the primary key. This is the primary key. In the course registration table, this is a foreign key. This is a foreign key. I just look at once. See here. See, practically the foreign key has nothing to do with the primary key tag of another table. But the point is, if it points to a unique column of another table, okay, it would be a foreign key. So the correct definition of foreign key would be the foreign keys are the columns of a table that points to the candidate key of another table. That's what exactly the foreign keys are. Foreign keys are the columns, okay, of a table which points to the candidate key of another table. Which are the candidate keys of another table. Okay. That means here if you say this is the this is a foreign key, this is a foreign key, but this is candidate key of the student table. It's the candidate key. That's what we are talking about. Okay. So here how to apply the foreign key constraint on the table. Example, you see the create table, student is a table name. This is the column name, data type, constraint, the primary key that is column name 2 is a data type, size, constraint. This is the column name and data type. These are foreign key. And this foreign key we are applying on another table on the course registration. That is the foreign key is student ID. This is now these are the constants. So these are the constants. Object constant is the check constant you can apply on the alter table. The default constant is the default constant on get default constant on alter table. Likewise, the constants you can apply on the tables. These are another commands are there here. Another commands here. Alter, drop command, DCL commands. These are the another type of the SQL commands here. The another type of the SQL commands. That is alter, drop commands, and DCL, TCL commands. These are all. A DBA can make changes to the table structure or column definition after the table has been created in the database. Okay. That is the TTL command, which is the alter table is used. So alter command it is. So these are the TTL command, data definition languages commands. So drop command is there. Drop. The drop is one more command here. The syntax here is drop table and the table. Okay. And purge will be applied to permanently delete that. The purge will be applied. So example here is drop table is the table. So this table name will be deleted from the database. So next one is purge. We are applying the purge command. The purge command will be applied to permanently delete those from the database. That is the drop command. Now DCL commands here is stands for data control language. Here DCL stands here is data control language, and which is used to control user access in a database. Okay, which is used to control the user access in a database. Now, this command is related to the security issues. Okay, so related to the data user access in a database, this command is applied is here. Data control language commands applied. Now it allows restricts the user from accessing data in database schema. So what is doing it is it allows restricts the user from accessing data in database schema. Database in database schema. The DCL commands that follows here. These are the following are the DCL commands. The following are the DCL commands. This is so one command is a grant command. Grant command. The grant command gives users access privilege to the database. This command allows specific users to perform some kind of specific tasks. So this is the job of the grant command. So what it does, it commands the grant command gives users access privileges. Okay, what kind of data to be accessed to the database? Okay. Some specific kind of task it will perform. So that is this grant command. And you can see the TCL commands here. TCL commands. TCL commands here is transaction control language. TCL stands, which are commit is there, commit command is there, rollback is there, save point is there, and the set transaction is there. Okay. Now these are the commands. So we have discussed all the chapters. So now, so nothing is left there. Nothing is left, and if you get any kind of doubt, you can contact the university administration team. They will go to, they will, they will help you preparing all these any kind of support if you want. The university people will help you. You can contact the administrative officials. Okay, this is the end of this 6 days course. Complete about the database management system. So most of the topics we have covered. The previous question papers you can refer to get for any kind of important questions. So we'll end up this session.